Okay, it's recording right now.
So hello everyone, welcome. I see that more people are joining us. We're almost around 10, so let's give maybe one or two. Oh, it's 10 already. So welcome everyone at User and Technology Talks, which focuses today at energy. But let's give maybe just 1 minute for some of you to still connect, and we'll start slowly our session. Okay, I see more of you connected. So welcome once again. My name is Veronica and I'm working for European Association of Remote Sensing Companies. And together with our partners who will also be introduced today, we're working on PARSEC Accelerator. It's a Horizon 2020 project, which has amazing goals and has achieved a lot in the last few years, actually two. And today with this event, we're starting a new series of our events, which is User and Technology Talks. On each of the series, we will be focusing on different sector, but let me maybe start with who are we and why are we really having this session today and why are we meeting? So basically, to just introduce you to PARSEC Accelerator, we are an acceleration program which focuses on food, energy, and environment sectors, and we support them with the use of Earth observation. We support the companies from these sectors to collaborate with Earth observation companies to create together new solutions and to basically help these three sectors to grow with the use of Earth observation innovation. Oh, sorry for that. So basically, we're in the acceleration program. We're giving the mentorship and the support to different companies from different sectors. And throughout the year 2019 and 2020, different companies, more than 100, applied to our acceleration program. And currently, after the second stage of the selection, we're working currently with the 15 international teams, cross-sectoral and cross-border teams, which each of these teams is developing a new Earth observation-based solutions. And today you will have a pleasure to meet two of them, but there are many more. So I invite you to go to our website and check what they're working on. And basically, why are we meeting then today? So what we would like to do is to get to know the sectors we're working with a little bit better, to know what are actually the things that are troubling you, what are the needs and challenges each of the sectors today, the energy, is facing. And then with our Earth observation experts and with our PARSEC teams, we will try to find answers, figure out how Earth observation can be an answer to that and can solve the current problems. So that's the plan for today. And based on that, we'll have a very basic agenda, but we're also open to you, to all of us who can hear me, not only our speakers. You have a Q&A section where you can type in your questions throughout the whole event. If you have questions more to our Earth observation experts, or if these are questions to our energy sector representatives, if these are questions to us, feel free to add them. You can also comment, not even questions, but if you agree with something, if you agree or disagree with something, you can also comment in the chat. And of course, we invite you to share information about the fact that you're here and if you like the event on social media. And then the plan for today is pretty simple. Of course, it's pretty flexible because we want to have a real conversation with you. So if you focus on something a little bit more, that's completely fine. Of course, we'll start with introduction of our speakers from both sectors. Then we will focus on identifying the needs and challenges in a discussion panel mode. And then our EO representatives will also let you know the Earth observation sector a little bit. They will also share their solutions and their pitches. And then we'll get back to this more Earth observation targeted conversation to see if these are actually answers for the energy problems. And then at the end of the session, but also throughout the discussions, we will be checking your questions and comments, and they will be used for our discussion. So feel free to type in throughout the whole session. If we don't use it for any of the discussions, it will be answered at the end in the last Q&A session. So that, I think, with that said, we can get starting. We should be today here for 2 hours, so you have a lot of time to discuss. Feel free to comment, and now I will give the floor to our moderator today, Salome Reyo from AVAESEN. Salome, the floor is yours.
Okay, thank you, Veronica. Could you leave sharing? Okay, thank you. I'm going to share now my screen. I hope you can see. One moment, because it was okay. So first of all, I would like to thank our speakers here in the energy session. And I'm Salome Reyo, and I'm the project manager at AVAESEN. AVAESEN is the energy sector representative in PARSEC Accelerator project. And AVAESEN is the clean tech regional cluster in the Valencian community area in Spain. And we have more than almost 200 companies associated to our cluster. And we represent around 80% of the sector. And we work with renewable energies, energy efficiency, climate change, circular economy, waste management, water management, and smart cities. And what are we going to have today during this session? Veronica has explained a little of this to us, but we are going to have first a debate with experts in the energy sector. We are going to have here today to Ignacio Osorio, CEO at Ampere Energy. We are going to have also to Jonas Redreche, I'm sorry for the pronunciation of your surname, sorry, Open Innovation Analyst at EDF, and Eugenio Domínguez, CEO at Hybrid Energy Storage Solutions. Later, we are going to have an Earth Observation session or slot. We will have to Dr. Panagiotis Kosmopoulos, another time, sorry for my pronunciation. He's associate researcher at the National Observatory of Athens in Greece. And in the last moment of the session, we will reach you innovation that we are having in PARSEC Accelerator with some of the consortia working with solutions with applying Earth observation to the energy sector. So we are going to analyze first which is the future of the energy sector. I would like to give you the point of view from AVAESEN, from our cluster. So we think that, or Europe is thinking that we are going to have that we call twin transitions. We are going to have energy transition and digital transitions. We are going to have decarbonization. It means that we are going to have power generation or more percentage of power generation with renewable sources. We are going to have digitalization. I mean, we are going to have a smarter transport and distribution networks. And we are going to have decentralization. We are going to promote, or we are going to have more decentralized energy production to give more power to the final users. So we would like to begin with the debate with the experts. And I would like to have with one of you first an explanation or a little review about your company. I would like to each one of you, Ignacio, Eugenio, and Jonas, explain about your company activities. And this will be the first intervention from each one of you. And later I will give you another time the floor to each one of you to have your opinion, or what is your opinion about the vision about the future of the energy sector. What are the most important technology innovation and trends that you see in the energy sector? Which are the market trends in the energy sector? Which business model innovations we are going to see? And about your challenges. Does your company or your sector have any challenge to solve? Okay, so I'm going to leave sharing the screen. And I don't know who wants to be the first. Jonas, Ignacio, Eugenio. So I see I'm going to do as I see in my screen. Jonas is the first, Ignacio the second, and Eugenio the third. So Jonas, first of all, could you give us an introduction about EDF, about what your company do?
Yes, absolutely. Can you hear me?
Yes.
Perfect. Okay, so EDF, I don't know, I will present it pretty fast.
Sorry, Jonas,
Basically,
we cannot hear you very well. There is, I don't know if I'm the only one, but there is a lot of noise. I'm the only one? Veronica, can you?
So unfortunately, it was so okay when we were testing 5 minutes ago.
Yes.
Now it's very, it seems like the connection is worse, maybe? Or you were without headphones? Yes, we'll move on, maybe try to reconnect your headset or something now.
Okay.
No, we cannot hear.
Maybe what we can do, can I talk so that I can solve my connection problems?
Okay, we can move Jonas if you want to Ignacio, and maybe you can try to disconnect or reconnect, or to try to test
Jonas, if you don't want to be the first, you just only say that.
It has been an excuse. Okay, Ignacio, could you begin, please?
Yes, of course. And thank you very much, Salome, and good morning, everyone. Before I start, I just wanted to double check my audio and video is working fine. I hope so. Yes?
Yes, perfectly, Ignacio.
Perfect. And first of all, I would like to thank you very much, ABAESEN and the PARSEC partners for the invitation, for letting us taking part of this interesting energy talk this morning. For those that you don't know about Ampere Energy, I will do this brief introduction of what we do, which pretty much will answer some of the questions that Salome is going to ask later in the debate. But we are a technological company. We are based in Valencia. We have our headquarters in Valencia. But we have also international presence in different countries in Europe. We are in Portugal, we are in Ireland, and we are in Benelux. And we have presence in South America, in Chile and Colombia. And what we are is basically a provider of products and services that are developed to help managing the energy transformation that we are all living. Okay, so what we do is develop a smart energy management system that we call SEMS. We develop smart batteries and we develop EV chargers. And in parallel to all of this, what we have developed is a cloud-based software platform to manage all those behind the meter smart assets in the most efficient way for both the consumer and for the different grid actors. So when we started the company almost 5 years ago, we have a clear vision of creating what we call digital energy communities from our smart devices and the software as well, which by the time, especially here in Spain, seems too far away and of course a little bit risky move. No? Don't ask my investors. But today, listen, we are in the brink to realize that the vision is coming together. And this is all that we are going to discuss today. So thank you, Salome. I don't know if you want to start with a question or do you prefer do the round with Eugenio and Jonas?
Yes, I'm going to do first the round with the presentation of the companies with Eugenio and Jonas. if Jonas can connect another time because he's having problems. So we move to Eugenio. Eugenio, please.
Okay, no problem. I can do it. So thanks so much, Salome, and also thanks so much to Abaisen and the PARSEC project for this opportunity. We are Harvard Energy Storage Solutions. I'm Eugenio Dominguez, I'm the CEO of the company, and we are pretty similar to Ampere, but in the other side of the grid. We are focused on to provide energy storage system and solutions for front of the meter or utility scale applications. But what we try to do is to provide those solutions on the most optimum way based on a hybrid approach. And a hybrid approach about to combine different chemistry, different technologies on energy storage to provide the most effective solution for our clients. So this approach came because at the end of the day, we had to provide multiple services on the grid. We are right now on a completely revolution of the grids that and this generation of grids with higher penetration of renewables, with higher flexibility, will need the energy storage as like the holy grail, as the key part that will improve the real management of the grid. But the problem is to design which technology, which chemistry, which kind of energy storage is the better for that. And our approach is to say that none of them or all of them. Just a smart combination of them working all together, looking for the synergy between technologies will be the answer. So, and this is what we do. We analyze the issues or the services that our clients, that are mostly utilities, have to provide to their grids to improve the flexibility of their grids. And we provide solution based on this analysis and based on our energy management system that improve the performance of this solution on the real-time application. And at the end of the day, we provide this like container solutions for our clients, whatever a renewable energy provider or a utility or a operator of a grid in order to do this transformation of the current grids to the new generation of grids. So let's move to Jonas.
Okay, thank you, Eugenio. As you can see, we are Jonas. As you can see, and all of you can see, we are having the version of the sector, or we are having different kind of stakeholders from the energy sector. We are having some company working more closely to the final user, another company working with energy storage, working together with the utilities, and now we have an utility. I hope, Jonas, we can hear you now.
Yes, I really apologize for my sound problems.
Perfect now.
Great.
Thank you, Jonas.
So EDF Groups, we are a global utility. We are basically the former national utility of France. We are the biggest electricity utility in Europe. We are present on the entire value chain. To give a rough idea of how big EDF is, we produce about 540 terawatt-hour of electricity per year, which is roughly 20% of the entire electricity production in Europe. So the message here I want to carry is whatever EDF does at the group level basically has a tremendous impact on the European goals and the Green New Deal, for example. I can look very fast on Spain. In Spain, we are not a big actor. We have been present for 20 years, but basically we are mostly doing energy efficiency services for industry. For example, with Fenice, we have another subsidiary working called Citelum, working with smart cities. We're also working a bit in the nuclear sector. Now we can talk a little bit about what EDF does in terms of energy transition. So basically, in EDF, we start from the European framework. Basically, what are the signals at national and European level for us to get into that transition? And right now, we have very clear guidelines from Europe. First, with the Green New Deal, we need to be carbon neutral by 2050. Right now, EDF is producing about 50 megatons of CO2 per year, which is about 1/6 of the entire CO2 emissions of Spain. And we need to go down to 0 by 2050, which is a huge challenge. Our objectives for now is to go down to 30 megatons by 2030, which would already be a 40% decrease. How do we do that? Mainly right now, we have two main plans that are structuring how we'll do this. First, we are trying to double our renewable energy capacity from now 28 gigawatts up to 50 gigawatts. Then we have the solar plan. We are planning to install 30 gigawatt new solar PV by 2035. And then we have a storage plan. We are planning to install about 10 new gigawatts of storage capacity with 8 billion of investment by 2035. So with that, we hope that we can contribute to the objective of Europe. Then I can talk a little bit about innovation and what we do in terms of innovation and maybe how we can interact with the innovation ecosystem. So at EDF, we're doing both open innovation, but also internal innovation. In terms of internal innovation, we are spending 710 million euros in research and development every year, which is the biggest of any utility in Europe. And with that, we are basically trying to get incremental innovation happening and try to just improve a little bit of products. But this is obviously not enough. We need to go more. We need to go in adjacent market and even in disruptive markets. And for this, we, of course, can't do it alone. We need the innovation ecosystem as well. This is why we are working a lot with open innovation. First, we have this part where we do proofs of concept and we are trying to kind of test new technologies, but we are also testing new business models and so. We are looking for startups in whatever sector linked to energy because we're a global company, so we can find interactions with any startup somehow. What we really value is disruption and also alignment with our business. And this is a point that is extremely hard to reach for us. We basically need to find startups that are disruptive, but also get well within our value chain. And this is really hard. Or we need to have such an interest in an area that we kind of create a new venture together with a startup and yeah, create some innovation projects this way. So basically, there's a lot we can do with the innovation ecosystem. There's a lot we want to do with the innovation ecosystem. There are big objectives to reach at the European level. And yeah, we hope to spark some discussions and yeah, find ways to collaborate in an open innovation way. It is very difficult, but we are taking that task and we hope to find ways to do that.
Okay, thank you, Jonas. So I think that the attendees are more or less seeing that the energy sector is a very innovative sector, that we are going to have a decarbonized sector, but I would like to see to listen the opinion of our energy expert about what is the vision about the energy sector in the future. Maybe we can start another time with Ignacio.
Hi, can you hear me?
Yes, we can.
Hi, everybody. Just a quick introduction from my end. My name is Navin Rajgare.
But Navin, sorry, we will give you the flow later, if you don't mind, because we are, okay, thank you, Navin.
Sorry, I thought I heard Navin, that's why.
No, Ignacio, sorry.
Sorry, I was on mute and I was trying to find the right button, but you know, it's a good question and it's a very wide question in our opinion.
Yes, I know.
But you know, what is a reason for the future of energy? Or I would say better, what is the present of our sector? No, even better.
Yes.
And what I would say is that for us, in the future of the energy sector is maybe getting the most out of digitalization and in bringing the concept of Internet of Energy to the full extent. This is, this is what we see. If we stop and think, the higher penetration of renewable energy that we are going to experience in the next years, plus the fact that a lot of this new generation is going to be distributed, plus the quicker EV electric vehicle deployment and the infrastructure, all of this is going to need the tools to manage the grid on a different way, a way that it needs to be smarter, it needs to be local, and it needs to be totally interconnected. So for us, for us, this is the vision. I think I said before when I was introducing my company, what we saw in Ampere from the very beginning is, okay, let's arrive to the digital energy communities and let's create value with our products all along the way. And I think we are getting there. This is our vision.
Okay, Ignacio, I have liked the Internet of Energy expression. Okay, so now is the time for Eugenio. Eugenio, which is your opinion?
Yes, well, first of all, I completely align with Ignacio. And my company is working on this market since the last 15 years, when nobody were talking about any storage, where nobody were talking about digitalization, where nobody were talking about these new trends. We have been crossing the desert during that time, but now we are on a completely different situation. Things are moving faster. We are on a very, very important revolution in the energy sector. And this is why I'm completely aligned with Ignacio that it's better to talk about the present, not about the talk of the future, because the present is the revolution that we are living right now. And in one of the important parts of that revolution is exactly the digitalization. We have the technologies in terms of energy. We have the renewables energy technologies. We have the energy storage technology itself in terms of the chemistries. We have the AV as a reality. But the real key thing to achieve a real interconnection of all those assets, of those technologies, is through the digitalization, is through the sharing of the information, the smart sharing of the information of every of those assets, and how we will manage everything together in real time. So the real challenge is, I think, is more related to how we will integrate that in terms of the digitalization, in terms of the information that we are going to share, rather than the chemistries or PV or renewable energy sources, because all of those technologies are already in the market. And this improvement on the digitalization, this improvement of the integration in terms of the data, in terms of the information of those assets on the grid, will improve how we will, about the prices, how we will improve about the cost of all of those technologies that will be the backbone of the new generation of grid. And so the real challenge and the real thing that we have to put the effort right now is to improve that knowledge, is to improve that digitalization process and how we will integrate all those assets on the grid.
And Jonas?
Yes, I will retake what the two previous speakers said, because I think it's totally I'm totally aligned with you. In general, there's a framework that says that the future of energy is a 3D: decentralized, decarbonized, and digitalized. And I believe both Ampere Energy and Hestech are two great startups working, or you're even more than startups, working with this. From a global level, I would say the most important is that in the energy sector, the world is blending. 20, 30 years ago, an energy company was producing energy, a bank was making loans, an IT company was producing software. Right now, everything is blending. EDF is working with smart cities, EDF is working with industries, EDF is working with circular economy, EDF is working with crowdfunding. And basically in the future of energy, like companies, like at least global companies, will work with everything linked with every sector, with mobility and with connected with the entire world, basically.
Okay, Jonas, because I think that energy is everywhere. Energy is in the cities, energy is in the companies, energy is everywhere. So I'm going to launch the last question with 3 questions together to each one of us. We are going to change the order now. We are going to begin with Jonas in this case. So Jonas, what are the technology trends? I'm sure that Eugenio and Ignacio, for example, are going to say energy storage, but what are the most important technology innovations, business model innovations that you see in the energy sector? And last but not least, do you see any challenge that is needed to solve that you do not have any solution at this moment? These 3 questions for all of you.
Yes. So in terms of new, like the future challenges, I would say, yeah, one is manage to go from a centralized to a decentralized system, really make everyone produce energy and so. Then like one really key part of the transition is cheap storage linked to flexibility. And I really highlight that point. And I guess my colleagues will highlight it more, but I think that one is really key to manage to get to a flexible, renewable future. Then we need to go out of just electricity, but also go into hydrogen and renewable gases. And we need to find a mix between electricity, hydrogen carriers, and renewable gases. We need a lot of innovation on this side. We need to get the price of hydrogen down to 2 euros per kilograms. In cities, we have huge challenges as well. We need, like, cities represent more than 70% of the worldwide carbon emissions. And we need to find solutions, smart city solutions for this. And then we have huge challenges in circular economy. We need to manage to circularize all the energy flows. We need to circularize all the hardwares that we're using in renewables, for example. And so in terms of business model, I would say the key is to have business models as a service. That is software as a service, or in the case of Eugenio, for example, energy storage as a service, or projects as a service, or basically business model as a service, so that clients don't have to put up front the capital cost and basically get into the use economy. In terms of challenges that we cannot solve at EDF, I would say that there are a lot of regulatory challenges. For example, in terms of decentralized energy systems, let's say take the example of Spain right now. It's not clear who's responsible of the decentralized energy system in terms of regulation, but also we are limited to 500 meters and 1 transformer, which is very limiting. So we have challenges on that way. In terms of technological challenges, I would say on the circular economy side, the challenges is really important. For example, we need to recycle our solar panels. We need to recycle our wind turbines. We need to cycle our energy flows. And we have a lot of startups, for example, in Spain that are doing that. We need to find second use for batteries. And I guess Eugenio will have answers to that. And I guess I passed my time.
No problem about time. So now we move to Ignacio.
Okay, so I think we are, what I see from Jonas' intervention now, I think we are going to be again quite aligned on this question. So I don't want to repeat myself, but I'm going to provide a couple of headlines of what I believe are the challenges, the trends in technology and business models. For me, I mean, the challenges are related to the electricity system. Okay, so Eugenio mentioned, the difficulty that is going to be integrate all the renewable resources and all the distributed generation assets. That's a reality. It's going to be a challenge. How we are going to be able to adapt the growing electricity demand and make it match with generation in real time. That's another challenge that we are going to have. The need of increasing energy efficiency. And here, what I would say is data is key. The value of data and how we are able to present that data to the final client is key. And also, all the challenges that are going to be related to self-consumption. Okay, Jonas spoke about self-consumption, and here I would like to give you some data. In Spain last year, we had around 500 megawatts. Okay, in terms of residential installation, that means that we have 20,000 houses, and only a few of those incorporated smart systems, batteries or smart devices that can control that distributed assets. And that's a problem. If we think about Germany, for example, 1 out of 2 customers is able to put, a smart device, a battery or a hub, intelligent hub, along with the solar panel. But here is when it comes other kind of challenges that are not technical. And what I mean by this is I'm referring to the lack of information and incentives for the final customer. This is a challenge for me in this energy world that we are living. The final customer is not able to understand yet the benefit of smart self-consumption, demand response, flexibility, aggregation. It's not able to, and this is important. It's a very big challenge. And the other one, referring to the legislation, Jonas mentioned as well, but I would say is the lack of agility when it comes to create a legal and economic framework to allow this new business model. This is a very important challenge. I think I don't want to be repetitive on the technological trends. I think what we see as a company, and this is within our scope, which obviously is not wide open, but in our world, what we are seeing is smart devices in every home, even with panels or not, because that way we can control the demand, we can do demand response, we can create sources of flexibility for the electricity system. Within that devices is going to be quite important, and this is something that we do from Ampere, is all the machine learning algorithms and big data analysis tools, so we can predict the way that the consumption is performed in every house. And finally, all the software that is cloud-based and is able to pull together all the grid edge data from the different systems to make it work. And from that, it appears a lot of business models. We can speak about energy communities and peer-to-peer trading. Well, when it's going to be a reality, we don't know. In Spain, I mean, we are one of the first countries that we have a little bit of that with the collective self-consumption, even though it's restricted to 500 meters and is restricted to some very static coefficients to do the delivery of energy between the different peers. But that's one of the business models that we are going to see very, very, very soon. And another business model will be around, in our opinion, around the balance provider. Is how an entity and a grid actor can aggregate different distributed assets and put it on the electricity system and get a value for that. Even participated in capacity mechanisms or flexibility mechanisms That's going to be the normal business model that we are going to see, and in fact, it's something that we are seeing in other countries in Europe, but in Spain is still to come. So that's my take. I don't want to take more time. Thanks.
Okay, thank you, Ignacio. I don't know if Eugenio would like to add anything or everything is covered.
I just going to remark some points because Jonas and Ignacio have touched all the really key things related to the challenges and the trends. I would like to remark something that Jonas has explained, that the world is changing, the utilities are changing, and they are mixing their business model with other kind of market or kind of way to do the things. And at the end of the day, this is the main trend that we are considering, that everything is getting hybrid as us. You know? Everything is a mix of solutions. There is a sole solution for this market. Only the mix of the EV, the mix of the energy storage, the mix of the use of renewable energy sources, the mix of the prosumer integrated on this market will be the answer to achieve a new generation of grid, a new generation of electricity energy market. But to achieve that, the data, the information, and how we manage that data will be the key thing. And related to that, we have a technological trend and a technological challenge that is related to that data. That is the integration of the 5G networks. And 5G network will be an important tool to achieve this real-time control of the system, real-time integration of the customer, real-time integration of the different assets working together in this hybrid world that we are becoming. So we have to see how to integrate this new technological trend on our system in order to manage that data. And at the end of the day, that generate a new, as Jonas has explained, a new kind of business model. In one side, because all these assets, all these system that will be implemented on the market will be like a live system that their behavior, their degradation, their use during its life cycle will be changing. So we have to be open to new business active models, new business models that will change during the life of the assets. You know, in the past, for example, on the PV market, we can have a PV business model just doing an Excel file, and you will know how much money you will earn in the day 25 of the year 10. But now things are going to change. The business model are going to change completely, and they will be active, and we will change day by day by the different uses that we are going to achieve for the different assets. And also it will include this the life cycle of the asset. It will include how we will do in a second life of the system, what we'll do with a second life of the batteries, of the EV or wherever. So this is going to be a very active business market that everything is going to change very fast.
Okay, thank you, Eugenio. So we have realized that we are having a revolution in the energy sector just now, not in the future, just now. We are living a revolution. And we have, I think that the three speakers have commented the importance of data and analysis tools of that data. So I would like to connect with the Earth observation data, but maybe Earth observation data is profitable or can be useful for the energy sector. I know some applications, like for example, application to self-consumption that has been already mentioned by our partner. So I'm going to from our speakers. So I'm going to ask our speakers from the energy sector to be listen very carefully, because we are going to move now to our Earth observation. And maybe I will ask you, I'm going to do an exam to, a kind of exam to Eugenio, Jonas, and Ignacio about our next speaker intervention. So I'm going to give the floor now to Dr. Panagiotis. Please see, you can say your name better than me, so you have the floor. I'm waiting for the presentation. It takes some seconds, like in the test, during the test. Maybe you can begin introducing yourself, Panagiotis. We cannot hear you. I don't know if you have, now.
Can you hear me?
Yes.
Okay, perfect. Okay. So, hello, my name is Panagiotis Kosmopoulos. I am an associate researcher at the National Observatory of Athens in Greece. And I want to thank you for this invitation, especially Veronica, Salome, and Francesca, for the nice collaboration of the past few months. At the National Observatory of Athens, we mainly exploit the modern Earth observation data and technology by developing solutions that are able to actively support the work of the energy sector, dealing inter alia with energy efficiency, net zero energy buildings, renewable energy nowcasting and forecasting, as well as with electricity and smart grid stability, focusing on the penetration of solar systems into the urban environment and scale. My presentation for this energy session today deals with the solar energy sector, and more specifically on the use of Earth observation data for smart energy planning and real-time management by exploiting the space technology, fast simulation models, and computer science methods. I will start mentioning that the need for dedicated Earth observation data is directly related with the need for optimal energy planning as a result of the nowadays increase of the renewable energy sources participation share in the total energy production and consumption mix, which until now is close to 22%. And the target for the next decade is to reach almost 30% globally, in conjunction with the overall influence of the climatic conditions from the irrational use of the produced energy. Indicatively, over the past 5 years, an estimated 15 gigatons equivalent of CO2 emissions was avoided with the use of renewables, a number that is expected to increase to almost 70 gigatons for the next 30 years. So this specific need for optimal energy planning requires Earth observation data and techniques in support to an efficient energy management, which has to operate as an integral part of the overall state administration. In Europe, the renewable energy planning and management is controlled by the local and regional transmission and distribution system operators, for which the useful information deals with the continuous monitoring and control of the produced energy by the distributed photovoltaic and concentrated solar power plants, the short-term forecasting for the effective electricity distribution, the operation of the smart grids, and the overall energy market, while the long-term forecasting is followed by the subsequent uncertainties, but is useful as well for the solar farms, energy producers, and the day-to-day market operations. To this direction, the ability to monitor, forecast, and manage the surface solar energy with the use of Earth observations is useful mainly in decision-making for the energy producers that exploit solar power plants, as well as for the electricity handling entities. Indicatively, in a recent report for the United Nations for the global energy production and consumption, they highlight that 30 years, the total discounted cost by the extensive use of solar energy in terms of operation costs, maintenance, and fossil fuels is expected to reach almost $10 trillion, indicating the basic role that such technologies will play next years, and the necessity for solutions that are based on the Earth observations. To this direction, based on the scientific and technical background of the past 5 years, at the National Observatory of Athens, in collaboration with the World Radiation Center in Switzerland, we developed through a €15 million project, the EuroGeo eShape, a holistic solar energy management system, the so-called sense, which is able to control in real time the solar energy production and balance the distributed energy supply and demand in collaboration with local and regional electricity handling entities. This system is based on fast radiated transfer models, cloud motion vector for accurate forecasts up to 3 hours ahead, numerical weather prediction models for 1 day ahead forecast, and high performance computing for massive outputs of the order of 20 million simulations in less than 1 minute, and an overall daily data flow of 150 gigabytes. It uses as inputs satellite data from the EUMETSAT Meteosat second generation in order to monitor and quantify the clouds effect on solar energy production, while for the aerosol effect, an impact to exploit the Copernicus atmosphere monitoring service. All these data sources are open access. And as outputs you produce operationally and in real time, the surface total solar radiation covering Europe and North Africa in high spatial, temporal, and spectral resolution of the order of 3 kilometers, 5 minutes, and 1 nanometer respectively, and to estimate the solar system's energy production, which applies to all scale solar plants, from big solar farms to small and medium rooftop photovoltaic installations at thermal environments. To the right is an example screenshot from a recently developed solar energy management web service, which is based on the NextSense know-how. It is totally open access, and I want to highlight that for each one of the 1.5 million pixels of Europe and North Africa, the user can retrieve in real time solar energy formation for 3 hours ahead and 3 hours back at 15-minute intervals. And for direct access to this web service and for more technical details, you can follow this link. Concerning a couple of success stories based on Earth observations. First, in Egypt, several actions took place the last 5 years relevant to the exploitation of solar power in collaboration with the Ministry of Electricity and Renewable Energy and the New and Renewable Energy Authority, for which we developed the official Solar Atlas of Egypt, and is now a government document. In this atlas, almost 30 locations were identified for the installation of new solar projects, and one of these locations was in Benban, where last year one of the biggest solar farms worldwide was completed, covering an area of 6 by 6 kilometers and producing annually almost 3.8 terawatt hours. Additionally, for the Magdi Yacoub Heart Foundation in Aswan, we developed an analytical business plan by using Earth observation climatological data for the installation of a new solar farm in order to cover the energy needs of the hospital and the residential area, indicating the necessity of Earth observations for smart solar energy planning and real-time management with the use of operational data and services. The second success story was in India, where we developed last year a dedicated solar energy nowcasting system in order to be optimized for the specific climatological condition of the region, like taking into account the monsoon, the aerosol sources, etc. And it uses the INSAT 3D satellite as a basic input data source, which provides real-time retrieval for clouds and aerosols. This work has been implemented in collaboration with the Indian Institute of Technology in Urki, in the northern part of India, and the National Institute of Technology Karnataka at the southwest part of India, where a sensitivity analysis performed for their rooftop photovoltaic installation. This Earth observation-based system is going to be used operationally by the Continuum company, which controls a big portfolio of solar plants across India. They will act also as regional solar energy data providers for the whole region, providing forecast data and forming the updated and modern local energy market by exploiting the Earth observation technology and information. As a brief conclusion, I believe that this technology and the extensive use of Earth observation data and services are able to provide access to accurate solar energy potential information, useful mainly for energy management and grid stability, while it can set up a roadmap in order to support users at any solar system scale, as well as the transmission and distribution system operators with open access solutions for decision making, promoting and supporting the sustainable development, as well as affordable and modern energy for all citizens. Finally, for additional information about the usefulness of Earth observations in solar energy exploitation, you can read the recently published article within the PARSEC Insights. Thank you very much for your valuable time, and I hope my point of view to be useful for the discussions in order to find ways to improve the work of the energy sector with the use of Earth observations, data, and technology.
Okay, thank you, Panagiotas. So I have realized, or I have understood, that Earth observation data could help the energy sector with forecasting that data to help with the energy planning, energy management system, as data for decision making for governments. I know also that energy observation data could be useful for maintenance of infrastructures in the grid. So I give the floor another time to our energy experts to ask about if they see any application of the energy sector on the if they see any application of Earth observation to the energy sector and concretely in their company, or if they see any added value of Earth observation to their companies, and if they would like to collaborate with any Earth observation company. So who wants to be the first? Eugenio, that he has, okay, Eugenio.
Okay, so thanks, Panagiotis, sorry for the pronunciation, for your presentation. It was very, very nice. And, you know, I think it's a very, very important and valuable tool for us, because at the end of the day, and it's something that maybe also Ignacio will be agree, you know, from the energy storage point of view, the main question that we have to solve is to decide which is the value, or which is the point of charge that we have to have our energy storage system. And it will depend on the kind of services that you will do, because you can think that, oh no, I have to have the system fully charged, but then if I have waste energy, I cannot do nothing. Or I have to have the system completely discharged to be able to absorb the energy. But that question could be improved through the forecasting about what is going to happen on our grids. And what is going to happen in our grids sometimes very, very related about the meteo, about the environmental conditions. And that environmental condition could be very well forecasted using the observation of the Earth. Just on a wide point of view, thinking about a country, or thinking about a very narrow view on a possible storm on a place, or a possible moment that a PV plant could have a drop or whatever. And to have that forecasting, to have that information to predict how I have to have our energy storage system share or discharge, or the point of share that I have to have, depending on the possible issue that I have to solve, is a key thing that we can improve through the observation of the Earth.
Okay, the use of such data and applications more or less are based on the new European energy target model, which has as a main scope the energy market liberalization and the creation of a single competitive electricity market. The main characteristic of this model has to do with the continuous intraday energy trading. So the operational exploitation of Earth observation data and such online tools for forecasting, nowcasting, is able to provide accurate solar energy short-term and long-term forecasts, which are crucial in the energy market, where on-the-spot energy prices are defined by supply and demand equilibriums. As a result, if the energy suppliers can have such accurate estimations for the distributed solar energy production from solar systems, this information provides them with a comprehensive advantage with clear economic benefits for their intraday and day-to-day market operations. And this is the reason why all the developed and the under-development Earth observation services need to be co-designed directly with decision makers and companies, and of course, solar energy producers. I will mention just an example of the potential benefits in the city of Athens in Greece, where we did a study about that last year, which can be summarized with two indicative numbers. 30.5 billion euros will be the total discounted cost by the next decade by the extensive exploitation and use of rooftop installations, for example, and almost 226 megatons of CO2 equivalent of emissions will be avoided, indicating the overall impact of the renewables penetration in smart cities environment and scale. Now, concerning the issue about the storaging, of course, it is directly related, since if you can have information about the energy production, then you can manage better the storaging and how you distribute then the electricity from the storage to the main electricity grid. So I think that more or less...
I think that we have lost Panagiotis. Yes, we cannot hear you, Panagiotis. Maybe we can move to Ignacio or Jonas. Ignacio?
Yes, well, I think, well, first of all, I would like to thank Panagiotis. I don't know if he's able to listen to me, but thank you very much for sharing your presentation and the main conclusion. Thanks. And absolutely, yes, I think Earth observation data have a direct application of what we do. So just for you guys to understand what, you know, the way that our system works are based on prediction and estimation. So that's very important. So our system works with three main predictions. One is the prediction of the demand. So we apply machine learning algorithms to understand better how the customer is going to consume. The second one, which, you know, here it comes the application, is meteorological data. So the better we have our estimation on how much solar resource is going to be, the better our system is going to work. And finally, the third prediction is electricity prices. Based on these three predictions, our system works automatically to make the best decision. For example, in the case of a battery to charge or discharge, or in the case of the smart hub in the home, well, to do demand response or whatever it needs to be. So yes, you know, I like very much. It has a direct application on what we do, and it has been very interesting to learn from your work. Thanks.
Thank you, Ignacio. Jonas?
Yes,
you want to ask?
Yeah, thank you very much for the presentation. It was really insightful to see the last development of space and the Earth observation. I believe, like, let's say like this, space and satellites are expensive, and we need to find a way to get like business models that make space cheap, or like that make that energy utilities can use space images for forecasting in a cheap way. So that I guess is like really the key to get space into the energy sector. And yeah, I really encourage the innovators to find the business models to make that. I already see some, but yeah, I think there could be much more to have like images as a service, forecasting as a service, this type of stuff that we already see a little bit. But I would like to go further than just the operation. And so I would want to go also on the maintenance, because Earth observation could provide really insightful information on the maintenance, especially with marine energy. Because when you're, for example, on the ground, I mean, it's really easy to just send a technician and fix the problem. When you're in the sea, the maintenance costs skyrocket really fast, because it's really hard to identify the problems, and there you need much more data. And I believe that Earth observation here could be more and more important as the energy sector is moving more and more into floating wind, floating PV, and offshore wind and wave energy and these type of things. I think that the Earth images here would be really interesting. But on the maintenance part, I would say Earth observation is in direct competition with drones because drones can provide a similar service of information, not the same way. And we would have to find out in which situation drones are better, in which situation Earth observation are better. And then obviously for designing this system, especially marine system, I believe that here also Earth images would have a really important role. And last but not least, in cities, I think it was mentioned in the presentation that Earth images for cities could be really interesting, especially, for example, if we have the images of the city from the sky, we can know where we lose energy. We can know with infrared, for example, where we could improve. We could cross, for example, illumination with traffic data to know where the illumination is not optimized, and lots of these things where business models could be developed to improve the management of our cities. That was it. Thank you.
Okay, Jonas. I think that you are going to listen later from Carlos, one of our PARSEC consortia that are receiving help from PARSEC for developing their business. I think that you have already listened to Carlos in other ABAESEN event, but he has a solution that is directly connected to maintenance of infrastructures. And here in the chat, you can also see that there is another consortium that is called Copernicus Blue that use the Earth observation to detect high-risk vessels that can cause damage. I'm reading the chat. That can cause damage with their anchors and fishing nets to submarine cables, electricity cables from wind farms at sea. And they are suggesting them also as a provider for maintenance. Okay, so I think that we are going to move last to our PARSEC consortia. I don't know who want to be the first, Carlos or Naveen. Maybe Naveen, that he has tried to speak. Naveen?
Hi.
Now is your turn.
Cool. Yeah, thank you very much for, again, thanks for the invite. I'll try to share my screen. You should have it now. Let me know, can you see my screen now?
Yes, but not in presentation. Okay.
How about now?
Now,
yeah,
perfect.
Okay. Cool. Again, thank you very much for the invitation. I'm sorry for cutting in a bit early. I thought I heard my name there. So my name is Naveen Rajgare. I'm a co-founder of a company called Village Data Analytics. And so we are supported by PARSEC and also the European Space Agency. So today I'll talk about how we are supporting the off-grid electrification market, especially in sub-Saharan Africa and remote part of the world, using Earth observation and machine learning techniques, actually. So, let's start with the problem statement. I guess it's very stark and very on the face that more than 1 billion people, which is 1 out of every 7 of us in the world, don't have access to any forms of electricity. They most live in fairly rural and remote part of the world. And we did talk in volumes about the availability of the data. In fact, there is nothing known about them. Where do they live? What do they do? What's the village like? Where are they exactly? What do they grow? What are they currently doing? Nothing is known. And the best way to actually electrify them is actually to build individual decentralized off-grid solutions. But the fact is that there's nothing known about them. How do you go about developing anything for these villages? The only way that we have been using, and we coming from the energy access market, is to do surveys, to send people in there, collect data about, okay, what are people doing? But as you could imagine, how can you possibly survey 1 billion people? That's just too many, and especially given that they live in a very remote place. They are also very costly, imprecise, and generally leads to a lot of project delays and also wrong projects being settled sort of set up in these remote villages. This is where we have been developing our solution. It's called Village Data Analytics. So what we do is actually we use Earth observation data mostly to automatically identify these villages and then to understand the suitability for off-grid solutions. Our unit is a village, so we go village by village by village by village to say what is the best solution to electrify this village. What type of demand are we talking about? What type of cost are we talking about? And how do we go about electrifying these villages? The idea is that we generate the required amount of data that can help de-risk these projects and quickly bring electricity to these people that obviously deserve, and would very heavily benefit from any access to electricity. So on the right-hand side, what you see here is essentially the software. I will actually be explaining how we're already using this in many different markets in the country, in different parts in Africa, Asia, and also South America. Quickly, but most likely would actually walk you through, the process that we have used. Quickly on the methodology, so essentially we just follow 4 different sort of phases of it. One is we use Earth observation, mostly both daylight and nightlight imagery to identify off-grid villages. Once you know the villages, then actually there is a second piece of bunch of algorithm that goes in there to then start extracting information about these villages. How big, what are they like, what's the density, what type of buildings, how many people, what is their access to road and everything. I'll actually show you some of the imagery about that. Once you know the village, once you have enough information, then you can start predicting what type of solution would best fit them. What would be the cost of developing those solutions? How are the demand curve going to look like in the village? And at the end of the day, then we put all of this information together in a web-based UI, because in our sector, there is literally, some of the data might flow in Excel sheet here, there. It's very difficult to really find one place with data. So we are also, again, building a web-based software where all of the data of all these villages can reside and people can use that for whatever their requirement would be. That's a visualization part. Identification. So as I said, we use 2 types of imagery, both daylight and nightlight. Daylight is to actually obviously figure out where the villages are. So we use a machine learning algorithm on daylight imagery, mostly actually freely available imageries to identify where the villages are. But in the part of the world that we work, we actually, so nobody there knows where the electricity grid is, not even the governments, not even the ministries. Very few people know where the lines are. Again, to identify where the lines are, you see here in the yellow line over here on top of Sierra Leone, we again use nightlight imagery. Again, checking those villages late in the night to see, do you even see some rays of light coming from them? And then villages or towns that have light then get connected by wires, as you see here in the yellow line. So pretty difficult to figure out where electricity is in these areas. So, but again, we build the algorithms to identify where electricity is and where are the villages without electricity. So all of these red dots here actually represent villages without access to electricity. In this particular case, we have 570 villages in Sierra Leone. Decent sized, good villages. Once you actually know about these villages, then we go into each of them villages to actually start extracting information. Again, how big are they? What's the demographics? What's the size? Here you could see we have actually extracted if these places have access to road. How far is it from a town? Whatever road comes in, is it a single village or is it a hub village which has multiple roads going to other villages? Access to water, what kind of agriculture do they do? What other additional infrastructure like public health center or schools and other things are there. 15-20 characteristics from each and every village that we identify. This is just another image. This is actually a village in Ethiopia where we are working with the World Bank. You could actually also see that we have actually identified the buildings using high resolution imagery. So we can very clearly know what type of buildings are there. Are there very large buildings, which generally mean that they are commercials or shops or hospitals and others. Really profiling the villages. Once you actually extract so much information, then comes the point about predicting, where again, one more algorithm starts figuring out what type of demand do we see, how many poles do you have to put, what will be the length of the wire, what type of revenue should we be expecting from these villages, and essentially figuring out if it is a viable mini-grid village, or is it a village that is fairly close to the grid, in which case you probably say connect a wire to it, or is it a village which is very less dense, dispersed, in which case you say probably the best way to electrify them right now would be to send in individual solar system for the houses. So this is that phase which actually predicts what to be done and also prioritize, because we're talking about thousands of villages in the country. So we actually prioritize villages based on where the needs are high, where the demand is probably going to be high. This is where it then comes into is to actually put all of that information together and have the priority list in a user interface where people could play around and access all the data and make the right decisions. So this is just two views of the tool, where one is a list view where you actually see where all the villages are. This is where you go deep into the village. Here we have already extracted information. This is from Ethiopia, actually extracted information from a bunch of these villages, has a school, has a primary center, and many other viability characteristics. So all of this information is readily available for people to use. So that's actually what we have done. At the end of the day, our tool, we are fairly new. We're a very small startup based out of Munich and Cape Town, but we have already started working in different parts of the world for different actors. Obviously, the governments and the large donors like the bank, the World Bank, USAID, the government of Nigeria, now Sierra Leone, Ethiopia, they have already started using our tool. But interestingly, there are a lot of private companies, all the small companies that actually build these mini grids and off-grid systems in the villages in remote part of the world. They have started using our tool as well. Our tool is also quite useful for investors to actually see where they should be supporting in terms of their investment. And now we are also speaking with a bunch of banks and insurers as well. Apart from electrification, the amount of information that we extract is now also being, going to be utilized on different other sectors, especially agriculture value chains, and also probably for impact in the assessment as well. I'll pause there. This has been what we have been doing in the last couple of years, and I'm excited to actually hear your questions and also perhaps get feedback on if this is the right tool to build.
Okay, thank you, Naveen. So I don't know if any one of the speakers has any questions from Naveen or comments, because I will give the flow final to the questions that come from the attendees. Now the questions from the speakers. Jonas, Eugenio, Ignacio, Panagiotis.
I could have, in terms of development, I think it's really, really important. One question, have you heard about the EDF Pulse Africa? Because we have a startup competition in Africa that is looking for this type of solutions. So that could be maybe interesting to connect with them. Yeah, that's my question. And what are your development plans in the future, in 5 and 10 years? And how do you see this market evolving in terms of electrification and using Earth images for electrification?
Right. So one, it will be very interesting to know about this startup call. We'll be quite interested in being a part of it. In terms of the market, we have actually seen that the off-grid market is really kicking off. So there are a lot of organizations that have started sort of building large number of sites. In the past, if you see, the solar home system market is actually has gone through the cycles and have become pretty mature. There are organizations that have recently raised $90 million and $60 million as a part of Series B, Series C. So you could imagine that that's actually there is a good amount of sort of funding that's getting on the market. In terms of individual mini grid markets as well, now we see a lot of traction. It's also buoyed by a bunch of investment that have happened. For example, in Nigeria, there's a 650 million project that the World Bank is running. A similar amount is now going to be done in DRC and Ethiopia. So it seems like the whole mini grid market is now also sort of set up to scale. And the only way we believe the scale would happen is if you have reliable amount of information. Otherwise, it just takes so much time to build individual mini grids. You have to go there, visit multiple times, especially with COVID, you can't even visit nowadays. So it just takes so much time, and we're just trying to decrease it and also have the transparency and scale the whole process of finding the right sites to build. And we're hopeful that this sector will really kick very quickly, get started and get to their bikes very quickly as well.
Great, thanks. Yeah, we should keep in touch for this.
Yeah, I'll definitely reach out to you, Jonas.
Okay, any other question or comment, Eugenio?
Well, just a comment. For us, the isolated grids and microgrids, mostly on African countries, is an important market, and these kind of tools could help us quite much on the design and the definition of those microgrids. One of the important challenges that we have in this kind of solution is the lack of data, the lack of information about how to define those microgrids, about how to define, to design the kind of microgrid in terms of the size, in terms of the power needs, in terms of the energy needs. So these kind of tools can help and accelerate the designing process and sizing process for this kind of applications.
Okay, Eugenio, so I think that I clearly see a connection between the PARSEC consortia and the energy sector. So if there is not any other question or comment, we are going to move and to give the floor to, to Carlos, sorry. Carlos, are you ready? Okay, we can see your presentation. Go ahead.
Yeah, thanks a lot to everyone, especially to PARSEC and more especially even to Jonas for introducing the topic. Later, I have to give you 20 euros. So we are part of the Romeo consortium, and our goal is not to compete between technologies, between drone and satellite, is to combine them in order to manage the vegetation. So what is the main danger, the main threat to power lines? Is the vegetation. 50% of the incidents are caused by vegetation. It can be the biggest single item in OPEX. And with wildfires, there are possibilities of legal problems due to the vegetation management. For example, in California, PGE was bankrupt due to legal issues. So right now, the main tool to monitor vegetation is the manned helicopters. Are manned helicopters, which are very expensive. They are pollutant and they have human risk. And as you can imagine, inspecting power lines is one of the most riskiest operation in terms of aerial operations. So what we are doing is to combine satellites and long-range drones. So you have the overview information using satellite information that is highly available, is inexpensive, and you have the detailed information of a drone that you can have LiDAR information, you can have visual information, you can have LiDAR information with up to 90% less cost than helicopters and up to 40 kilometers range. So just to give you an example, in Germany, you can have the overview of the grid. So you have all the grid, and in the hotspots, in the areas that have the threat of vegetation, that you detect with the satellite that they have the problem of vegetation, you deploy long-range drones in order to find exactly where you have to manage the vegetation. So you change a blanket way of dealing with vegetation for a surgical, a very precise way of dealing with that. So with the drones, you can actually have not only the vegetation management. In addition, you can provide the mandatory inspection over the power line. So we are two companies, Life.io, that they are our German partners. They are a wonderful team of more than 30 members. They have different clients across the EU and the US, some of the biggest utilities, and they have just achieved a Series A. And we, FUBEX, our goal is to enable the long-range drone flights. We have achieved the first and only long-range authorization to fly over power lines in Spain. We are working in the first EU remotely controlled power line inspection with Naturgy and Vodafone. So you can control the drone from Madrid and fly it in France, for example. And we have 3 patents among other milestones. In the next 3 years, the sector of power line inspection is going to change dramatically, and we are really thankful for PARSEC to give us the opportunity to lead this new market. Thanks.
Okay, thank you, Carlos. So, Jonas, what do you think of the combination of Earth observation and drones?
Absolutely. I think it's really, really interesting how you're combining both. And actually, the project you had with Naturgy, I saw it like a couple of weeks back, and I was really impressed that you got the authorization of flying outside of human vision. My question would be, do you think from a regulatory perspective, is it possible to do in Spain and even like in other European countries or over the world? Like, how does the regulation look like? And how will that, how will this regulatory barrier kind of get dropped within the next couple of years for this business model to really take off?
Yeah, for sure that the regulatory issues are the biggest issue in the whole drone market. You can see a lot of drone manufacturers that they say that they can fly a lot of kilometers, but at the end of the day, the main issue is what the regulation allows. So we see that the new regulation, the European regulatory framework that has been applied from this January, is going to allow a lot of operations. However, I think that the authorities' mindset is a very conservative one. So it's very important to work with them. So in our case, we have collaborated with Naturgy, but even more important with all the Spanish industry in order to go to the authorities and to collaborate in order to perform safe flights. And that's key. This is a huge market that is going to open, but I think that no company alone can take the sector to the next level. So if we want to replace manned helicopters, that for us it doesn't make any sense right now at this stage of the technology. We have to work together in order to allow this. And speaking about beyond visual line of sight flights, that is 10 kilometers range, and we can. If you are curious, we can discuss because there are a lot of layers in the regulation, and there are around 400 pages of fun. Beyond visual line of sight flights are going to be allowed, we think, in this year, next year. But allowed doesn't mean that everyone is going to be allowed to do that. So you need a validation of systems. You need a lot of requirements in terms of operation. So it's going to be a huge market, but there is a lot of requirements that have been to they have to be taken care of. Okay,
so I think that it happens more or less the same than in the energy sector, that technology goes faster than regulation. So any other questions or comments from the speakers to Carlos? No? So if there is not any other questions, Veronica, I think that we can move to the questions from the audience. Yes. We are perfectly on time. I think that we are earlier than planned. So
yes, good timing, and thank you very much, everybody, for your presentations, and thank you for the questions. So we have a few questions. I will start with the ones from the chat. Some of them are actually directed at some of our speakers. I think Jonas is the most popular one among questions in the chat. So the first one is, I think because Salome also mentioned that one of our PARSEC beneficiaries also mentioned their solution regarding maritime and offshore monitoring. And this is also a related question. So what kind of insights would be of value in the maintenance of offshore facilities?
To be totally honest, I'm not an expert in offshore, so I don't know exactly. But if I see our wind farms and I had to guess what exactly they would need, I would say basically like if, for example, you have a floating solar. Like looking from the top and see, for example, the panels that are hotter than the others. That would be a really interesting thing. In terms of wind and like, the wind energy, I would say like know exactly the wind speeds and maybe the different temperatures, the different pressures at every moment would allow to make predictive maintenance. I know there's a startup that is called Aeolus that is really good at like using like on-site data offshore to design like offshore wind. Maybe there could be this type of services with Earth observation. I don't know. It's I'm just trying to infer here.
Okay, no, but that's okay, and actually that does make sense, and it's a good input, I think, for the Earth observation solutions, and also with the use of in situ data. Then we have another question. It's a question / comment, and let me read it. So, shouldn't satellite imagery be used for its strength? You have access to whole globe. Let's leverage on that to scale until you can spread the fraction of the capex in the final pricing, so then the data actually becomes cheap, much cheaper than the drones plus access to remote areas. It was also a comment to Jonas, so if you want to address that, feel free.
Yeah, I mean, the thing is that when you look from a big group perspective, we're always like balancing different options in different cases, both economically and environmentally. And for certain cases, absolutely. For example, for trying to identify villages and villages that don't have like electricity connection, absolutely. I mean, you're not gonna do it with drones. That's just impossible. In terms of, for example, maintaining an onshore wind farm, I mean, usually drones are fine. Like, for example, with local distribution grids, if it's just maintenance of local electricity grid, I don't know. I feel that on these use cases, for example, drones are better than Earth observations. I hope I'm looking forward for you to contradict me and tell me that I'm wrong and to enrich my insights on it. But definitely I see Earth images in many different use cases. Absolutely.
Okay, thank you very much. Okay, we have also questions coming in Q&A section, and we have actually more companies sharing that they're working with the offshore wind industry. So there is a potential to find such a service and look for such a service. Okay, now a tricky question regarding sustainability of renewable energy, because as you know, it is tricky to what to do with solar panels on the windmills, wool blades after they reach their end of life. Can the EO help with that? It's mostly a question to our Earth observation innovators. Do you think any idea on that? I think it's a tricky one actually, if Earth observation can help on that. But any ideas on the top of your head?
You mean how Earth observation can support what? The sustainability of the photovoltaic?
Yes, I think that's what the question meant. It's pretty vague, but I think we can just like, how can then Earth observation be connected to sustainability, or as you said, support sustainability of renewable energy sources?
First of all, this is a very useful tool in order someone to perform his own market operations. So if someone can sell energy with control to the energy market, then the sustainability is something that can happen. Another issue that I heard from the other speakers is concerning the maintenance. What we currently do in Egypt and in India is that we continuously monitor the solar energy production based on Earth observations. So once they have some values up or lower to this estimation, this means that something probably happens. In most cases, this was true because in Egypt, they had before 1.5 months a huge dust event, and they have not sent the maintenance team in order to clean the panels. And we saw that information from Earth observation. We informed them about that and directly sent the team for maintenance in order to clean the panels. And they reached almost 12% more income in that day. So I think the sustainability is directly related with useful information in order to control your energy production and then to perform some market operations and to increase your income in terms of, for example, if you have some information for the next 2 or 3 hours about your energy production and you see that you can distribute your energy to the grid, or you can store the energy and to sell afterwards. These balances form the energy market, but this is not very common in Europe until now. In Southern Asia, they do this market operation very often. But in Europe, it has to do mainly with the transition to a more digital operations in order to include in all this stuff the Earth observation data and information about the energy potential, the energy demand, size of things, and all that stuff. So my point of view is that sustainability for the photovoltaics is directly related with use of information from Earth observations, from satellites and from drones, because you can see the situation of your solar farm from a drone, but not continuously. For continuous monitoring, you just need a geostationary satellite in order to see all the time the situation there at the higher possible resolution.
Just to comment on the sustainability angle, especially coming from the rural markets. Obviously, most of the rural areas in the world are accessing diesel gensets. So the mini grids are mostly actually not genset based, they're mostly panels and batteries. So there's a lot of CO2 that you offset, and obviously that is helping in the sustainability angle. In terms of what you do on panels and batteries that have been lying in the villages for a long time, or decentralized systems. Again, Earth observation can definitely help. I'm not sure if you have come across, there was a work that Google did in the US where they actually started identifying panels on top of everybody's rooftop. So if you have that level of information from every rooftops where the panels are, then you could potentially figure out when it was up there in the roof and when it is not there and how these things are changing. You could perhaps track it. If it can be done in the US, it can be done across the world. But I guess what's the most important thing is, how can that information be used for what, and where's the business for that information? Who's going to pay for it? Because these are expensive, satellite imagery. And the thing especially from our own knowledge in the market is that there is no second market for both the panels or the batteries. So if it has died, there is very little business initiative around it. So yes, possible information can be extracted, but we have to figure out how that information can be paid for, how that can be used, and who's going to use that information for what use case. I guess the best sustainable thing in the world would be that if the information can be used to make a decision and there is some business or subsidies or funding available for people to use that information to act on something, then things become sustainable. That's also a little bit of my personal view on it.
Thank you. Thank you very much for commenting, Nadim. Okay, let me move on to another question. One of the identified challenges was regarding alternative energy sources. Does EO have the capacity to detect these? It's again more the Earth observation question. And I can see that also we're having one more question which was answered, but I will get back to that in a second. So any ideas on the alternative energy sources and EO?
You mean alternative sources of what?
What do I have here? Alternative energy sources as such.
Alternative energy sources for what? I don't understand the question.
Hybridization, I understand, but I don't know.
You mean something to work in parallel with photovoltaics or something like that, or alternative in terms of using Earth observations?
I see. Oh, we're having the answer. So answer regarding the question. It's about the use of hydrogen. So what could be, how Earth observation could support there?
This is a good question. How Earth observation can support the hydrogen. For the handling of hydrogen, it cannot support, but it can support if you produce hydrogen from renewables. In order to control the production. This is a common practice in Morocco and in Italy and Middle East, they produce hydrogen from renewables. So their Earth observation can support in order to know the production flow of the hydrogen. But directly to hydrogen, I cannot think how it can be useful.
So maybe Eugenio or Jonas, because there is a correction or someone in the someone using my name in the chat, but I'm not me. Is telling that hydrogen is not an energy source, it's an energy vector. So maybe Eugenio and Jonas could explain which could be the possible necessities for hydrogen.
Exactly. Hydrogen is an energy vector. Hydrogen is a way to store energy. It's another way to do the energy storage. And at the use of the Earth observation, it will be in the same way that we were discussing previously. Is how I'm going to manage that vector, how I'm going to manage that way to store the energy, depending on the condition, depending on the circumstances in terms of meteo, in terms of possible change, fast changes on the grid circumstances related to the differential in production. So as far and as better we will have information about those changes, we will be able to manage in a best way both energy storage or hydrogen as a vector, hydrogen as a storage.
Okay, thank you very much. If anybody wants to comment, please feel free. I will also get back to some of the questions in the chat about that was about the offshore industry. So we did have that. Okay, I think we addressed all of them. If anybody feels missed, oh yes, there is one. Are there any links to open R&D calls by EDF you would want to draw our attention to? It's a question to Jonas clearly, but if you have anything to comment upon that, please.
R&D calls, not really, because like the R&D works like at EDF, we don't do like startup calls for R&D. That's not really the way we work. But we do have lots of startup calls that are not driven by the R&D, but that are more driven like by the innovation team. And there, of course, we have the EDF Pulse Europe with a deadline in April, I think, where there are lots of prizes to win. Last year, one of the Iberian startup won a prize, Reciclalia. We have EDF Pulse Africa. We have EDF Pulse US. We have EDF Pulse UK. We have EDF Pulse India. We have EDF Pulse China. And we have EDF Pulse Brazil. So more or less wherever you are, you can apply to an innovation startup competition by EDF, driven by the innovation part.
Okay, thank you very much. I hope that that answered the question. In the meantime, I'm not sure if everybody could see that we had a question from Marco, who is working with nano satellites, and his question was how the Earth observation, like for what applications could the use of nano satellites have in energy? And so far, Panagiotis answered that it will be useful for solar energy production monitoring for the maintenance purposes. But if our Earth observation representatives also have other ideas, please feel free to add. More? No? Okay. We also have more and more companies sharing their ideas and their products they're providing from the Century project, which is also one of our PARSEC team, who provide automated detection of photovoltaics or thermal solar panels and estimate energy environmental impact. So that's also with the use of Earth observation. Thank you for sharing. And also we have Tatiana Suarez from Flightform Insights, and they provide data service based on Earth observation to the offshore wind industry. And you also have links to that as well here. And one report share to take a look at. Okay, for the moment, I think we managed to answer all your questions. If anybody feels neglected, please feel free to retype your question if we missed it somewhere. But I hope it's all. And I think if there are no, oh, Panagiotis, you raised your hand. I don't know if it's
yes. Veronica, I want to add something about the cost of the Earth observation data, because many of you have similar questions about that. There are several big European Union funded projects that forward the open access use of this data. So the application I present you today is totally open access. The data are for free. And any company that is interested about short-term forecasting data for any location in Europe and North Africa, they can ask us to provide them with an FTP URL in order to provide them this data. It's an open access data. European Commission forwards this in politics in order to use such data for free, not for pay. So in the framework of many projects, you can provide applications not only providing directly satellite data, but added value products like the solar energy potential in real time for monitoring purposes, for short-term forecasting in order to perform energy market operations, and long-term forecasting in order to plan the next day maintenance of solar farm, or to perform directly energy market operations for the next hours for the intraday operations and the day-to-day market operations. So all these data are open access, and the majority of them are for free.
Okay, that's an important part, and I think that's something that maybe other sectors are not aware of, that Earth observation is usually contributes to cost reduction. So so for sure that's important to emphasize that here. Okay, I don't want to push anybody, but we're also getting closer to the closure of our time here, and I think we lost one of the speakers on the way. It's not a good sign.
Yes, Ignacio has apologized, but he has called an urgent meeting from the boss.
Okay, that's okay,
okay.
Sure. Okay, so I would like to thank you all very much. Of course, all of our speakers and PARSEC beneficiaries who joined us today, and the audience. Thank you for all your questions and all your comments and sharing what you're doing with energy and Earth observation. I would like also to use this occasion to invite you to our following events, because as we said at the beginning, this is the launch of the series of PARSEC events. We'll have 2 more such meetings, our user and technology talks. The following one will be dedicated to food sector, and it will happen on the 24th of February, also as 10 to 12. And 2 weeks later, we'll have the environment sector meeting. So we'll discuss what Earth observation can do for these other two sectors. So we hope you will stay with us and register for the next one. We'll keep you posted. Maybe I will just share the link in the chat in a sec. And thank you very much, everybody. And I wish you a pleasant day. And thank you once again to each one of our speakers, and of course to Salome for moderating the session.
Thank you, Veronica. And I hope that this is the first step to join the Earth observation and the energy sector. Okay, thank you to all of you. And I will...
Thanks so much for the opportunity.
Okay, I will put the link available about the recording of the session to Veronica, and she will share with you the link.
Yes,
okay?
all the attendees will receive the recording, and also will share with you the links to register for the next sessions if you like this one.
Okay, thank you very much to all of you. Have a nice day.
Thank you very much. Thank you,
everybody.
Bye bye.
Bye.